Hello viewers, you are welcome to my YouTube channel. So into this video we have this integral. So integral from 0 to 1 of arctan of x then over x dx. Okay, so that's the integral I want to solve for today. So if you are new to this channel, please don't forget to subscribe, like, comment and share. Alright guys, so let's dive into the solution. So let's remember that we can write a series representation for the arctan of x. Okay, so we know that for absolute value of x less than or equal to 1, so we know that the arctan of x will be equal to sum of n from 0 to infinity of minus 1 raised to the power of n over 2n plus 1 then multiply by x raised to the power of 2n plus 1. So don't let us forget that. It's very important. Okay, so instead of us writing arctan of x, we can just replace arctan of x by its summation or by its series representation. Are we together? Then if we do that, we are going to have the following. So instead of writing arctan of x, we write this. So we are going to have integral from 0 to 1 then of sum of n from 0 to infinity of minus 1 raised to the power of n over 2n plus 1 then multiply by x raised to the power of 2n plus 1 then divided by x, okay, dx. So we can bring out the summation sign, and then if you apply the law of indices right here, x raised to the power of 2n plus 1 divided by x. So that will be x raised to the power of 2n plus 1 minus 1. And that will give us x raised to the power of 2n. Okay, so you can bring out the sum. So we have sum of n from 0 to infinity of minus 1 raised to the power of n over 2n plus 1. Then we have our integral from 0 to 1 then of x raised to the power of 2n dx. Alright, so next thing you are going to do now is to integrate this. So if you integrate this, what are we going to have? So we are going to have the following. So we are going to have sum of n from 0 to infinity of minus 1 raised to the power of n then over 2n plus 1. Then if you integrate x raised to the power of 2n, so what are we going to have? We are going to have x raised to the power of 2n plus 1. So we have x raised to the power of 2n plus 1 then over 2n plus 1. So you apply the limit, that is from 0 to 1. So if you apply the limit, so we are going to have the following. So we're going to have sum of n from 0 to infinity of minus 1 raised to the power of n over 2n plus 1. So we apply 1, okay, so we input x to be 1 raised to the power of 2n plus 1 will give us 1, okay, and if you input 0, that will surely give us 0, okay. So what you are going to have now will be what? 1 over 2n plus 1 then minus 0. So we have sum of n from 0 to infinity of minus 1 raised to the power of n then over. So 2n plus 1 multiplied by 2n plus 1, this will surely give us 2n plus 1 raised to the power of 2. Alright, so before I write out the closed form of this sum, so I would like to remind us this general sum. If you have sum of n from 0 to infinity of minus 1 raised to the power of n then over 2n plus 1 raised to the power of s, so this will give us beta of s. So this is called the beta Dirichlet function, okay. So that is beta of s. Are we together? So in this case, what is the value of s? So the value of s is 2, okay. So we can have beta of 2. So and beta of 2 will give us what? The Catalan constant g. Catalan constant. And this is approximately equal to 0.91596555941. Okay, so that is the answer to that question, and we have a good result. which is a constant in mathematics, the Catalan constant. So if you like this kind of video, please don't forget to subscribe, like, comment, and share. Thanks for watching. See you next time.